Tēnā koutou katoa, no mai, haere mai, ki te Aotearoa Food Safety Science and Research Centre. Ko Vivian Hunt aho, ka nui te mihi nui, kia koutou katoa. My name is Vivian Hunt, and on behalf of the New Zealand Food Safety Science and Research Centre, I'd like to welcome you all today and thank you for joining us for our Spotlight on Food Safety Science seminar. And today I'm very excited to welcome Dr. Stephen Hill and Alec Foster from Scion, who are going to talk to us about materials and packaging of the future, moving from unsustainable line to a sustainable circle, the need for a circular bioeconomy thinking. So what we're going to do is Stephen Hill is going to start with the talk, and then Alec will continue. So Stephen Hill is the portfolio leader for the high-value biorefineries at Scion. His portfolio covers research areas exploring and extracting chemicals for applications in the high-value, low-volume markets such as nutraceuticals, cosmeceuticals, pharmaceutical intermediaries, and fine chemicals. As you probably know, Scion works with a number of government agencies such as MBIE, MPI, and Callaghan, and industry to ensure that they're delivering on the roadmap for 2030 that will see New Zealand rely less on imports and the petroleum industry for high-value chemical ingredients. Stephen's expertise is in the nanostructure of cellulose in plant cell walls. He's currently commercializing nanocellulose from New Zealand seaweed in collaboration with Agri-C New Zealand Limited. He has a background in analytical chemistry and a PhD from Victoria University, Wellington. Previously, he was a research leader in analytical chemistry and a science leader for the biopolymers and chemicals group at Scion, where he's worked for about 20 years. So we have a real expert on the call this morning, and just to remind you that if you have questions, put them into the Q&A. The chat has been disabled. So, and we'll cover those questions at the end. So, Stephen, if you'd like to start, that would be great. Thank you.
Thank you very much, Vivian, and thanks to everyone for joining us this morning and giving us the opportunity to talk through some of the thinking that that we're having at Scion and some of the science we're doing as well. So, it's a fact that we're moving away from an oil-based, petroleum-based world, and that there's a lot of materials and chemicals which come out of the current oil industry that are going to need replaced. And it's not a matter of do we replace them, it's a matter of we're going to need to replace them, or we're going to have a very different world and probably a lesser world than we currently live in. So this particular slide at the front with the map is because we're part of an international consortium looking at how biorefineries can be implemented on the global scale to make up the shortfall as the oil industry sort of winds down. But it was really just to remind the globe that New Zealand's this little country at the bottom of the map. Now, one important factor for New Zealand is we're biomass rich, so we don't really use our oil resources, which is good, but we can be a reasonable player if the world is transforming itself into a circular bioeconomy. So that means that one waste product will become the feedstock for another product further down the line. Oops, sorry. Okay, so what we were talking about is so we're talking oil-based versus biomass-based feedstocks for refining. So these are the inputs. And we're at a crossroads where we can now make a decision that we're no longer going to be taking resources from under the ground, we'll be rather taking sustainable resources from above the ground. Now, the oil industry does have about 150 years on the biorefining industry, but a lot of that knowledge which has been generated from the oil industry can be transferred into the biorefinery space. So from a knowledge point of view, we're ahead, but from a capital investment point of view, we're quite a far way behind. This is just to remind everyone that we're sort of living in a blip at this current time frame. Historically, so before black goo started to become so important, we lived off the land, and we actually had a little control over what we did and what the land was doing. So even going back further, we were hunter-gatherers, where we really didn't have any control of how we lived. We just sort of followed nature, patterns of nature. And then as time came on, we did farming, but again, we were living off the land. Then came the oil period, and we shouldn't vilify the oil industry completely. I mean, there's a lot of excellent science and technology that's been developed because of the oil industries and because of our reliance on oil. But that's coming to an end. So we're going into a new world where we're going to be living with the land. We're going to make smart decisions, and we're not going to lose any of those technological advancements that we've made in the last 100, 200 years, which were predicated on compounds and materials which have predominantly come out of the oil industry. So what we're saying is we can replace like for like. So here's an example of making acrylic acid, which goes into your glasses, paints, contact lenses, numerous materials. Now, it's fair enough to say this is a commodity product, but it's just an example. So we can either go down the oil route, where we extract a chemical, we purify a chemical, we then modify the chemical, and we end up with the acrylic acid, or we can do a similar route. In fact, it's less steps, by starting with a plant and starting with waste material from the plant. You don't have to use the core material, like say the bit that you want to eat or the bit you want to turn into a 4x2. It also gives us the unique opportunity to stop and think, are we using the right products? And Alec will talk a little bit about that later. But for example, we could make bio-based polyethylene. But now we can ask ourselves, did we really need polyethylene in the first place? Or are we just using it because it's what we've got? Would some other polymer which has a better life cycle, which is going to be better for the environment, be a better target? So we can also question, are we just using things from the petroleum industry because we always have, or was that the right material to be using? And if it wasn't the right material, let's have a look in nature and how we can do some chemical biology or normal chemistry and develop what we really wanted, and safer for the planet type products. Just to remind people that it's not because we're running out of oil we're doing this. The planet's in crisis for a very different reason, and very much like the Stone Age did not end because we couldn't find any more rocks. The oil age will come to an end before we've got all the possible oil we could have extracted from the world. And even, but that's been recognized that in a Nature paper, I think it was about 6 months to a year ago, there was an article which showed that for us to have a 50% chance to reach the 1.5% climate target of the Paris Accord by 2050, we would have to leave possibly about 80% of the current easily accessible oil in the ground starting now. Just to point out that plants are more than just single use. I mean, we might grow a plant for, well, an example would be corn. Corn in America, you grow corn, but now there's also an ethanol industry, there's a polylactic acid polymer industry, and we can do that with pretty much any biomass. And we should be seeing the entirety of the biomass we grow as being a potential resource for filling in some of these holes that we're going to start to develop as the oil industry winds down. So this is just an example of some trees, but it could really be any plant in some ways, just showing that there's a myriad of uses that cut across a large number of industries. So really what's stopping us doing this now is really just a lack of capital investment, not a lack of technology. In my particular area, in terms of the volume value pyramid, I'm looking at the top of that. So looking at how we replace some of the materials which we currently go into cosmetic formulations, nutraceuticals, fine chemicals, and pharmaceutical intermediates. This has the advantage for New Zealand in that you don't need massive biorefineries because you're looking at lower volumes. This is just a bit of a case study. Now, this is going to be focused on Pinus radiata bark, but again, it would be true for any biomass. We've had a program running for 5 years, which has been looking at what we do with all this pine bark. We export a lot of logs, and there's been a period where we've had to debark them due to regulations around phytosanitary chemicals. And Even without that, though, we still generate a lot of bark. So there's about 2.4 million tons of bark annually deposited all around the country from the forest industry. And of that, probably about 700 to 800,000 is really accessible. And the idea is to say, well, do we need to leave all of that biomass in the forest? Now, a certain amount of biomass left behind, be it in your farm paddock or the forest, is a good thing that helps regenerate the soil. But the total volume that we're currently just ploughing under or leaving is not usually required. So as you can see, this program was well placed in terms of international and national collaborators. And let's move on. So about 87% of New Zealand plantation forests are Pinus radiata, so that's our main feedstock. There is about 2.6 million tons of bark, and it goes through various processes, but a lot of it ends up in landfill. A small amount goes to landscape, but a surprisingly small amount. So we've actually got a really large bioresource that we can be using better. What are we doing? So we're taking the logs, we're taking the bark off. Now, if you went to the store and brought a ton of bark, it would run you about $250 a ton. If you can process that and extract some of the chemicals, you can be looking at low-hanging fruit like the tannins and hemicelluloses, which run at about $4,500 to $6,500 a ton. Or you can do some further processing and turn them into fine type chemicals, in which case the price balloons out to about $10,000 a ton. And remember, this is starting with the material that had a value from your garden centre of $250 a ton. In fact, in the manufacturing of these generation and generation 2 products, we actually don't really take too much of the total mass of the bark away. So either A, you can sell it back to the garden centre and they can still sell it for $250 a ton, or alternatively, this can be compressed into a coal replacement. So this is just a little mass balance we've worked out given the work we've done. So the bark's about 4 to 8% the mass of the pine tree. If we had a biorefinery processing about 50,000 tonne of bark, we could expect about 1,200 tonnes of suberins. Now they're fatty acids, and the waxes are also fatty acids, but fatty acids plus fatty alcohols, and of course they have application in human health and cosmetics and food products. You've got the phytosterols, which immediately go into human health and nutraceuticals. You've got the carbohydrates. Now the carbohydrates arguably would be a good source to feed into fermenters, and you could be making anything from medicines to novel polymers that Alec will cover. So there's about 4,000 tonne of tannins that can go into traditional tanning of leather. And that might be vegan leather, as I'll call it, which is based on fungi, or it might be traditional hide-based leather. Alternatively, some of the low molecular weight tannins can be used as food additives. They're powerful antioxidants, and there are companies already that sell and provide tannins for human health. The resin acids, they tend to be more useful in the resin industry, and then I'll move on to the last bit, which is the solid residue left over. Still represents about 80% of the mass of the bark, and that can be compressed into what you're looking at there is a highly densified residue from after we've extracted out all of those chemicals, and that is not exactly the same energy content as coal, but it's within spitting distances. So that could be used as a partial coal replacement, and depending on the size of your operation, maybe a complete coal replacement. Also, that material, if you do have a biorefinery, could be used to run the process heat of your biorefinery, therefore making it less dependent on external sources of energy. So in terms of the value pyramid and bark, so we've got all of these extracts we can take from bark, and then they sort of fit along this whole volume pyramid. So what are we talking about in New Zealand? Well, we're talking about moving away from the idea that we need massive plants in a single location. We really need to make our biorefineries fit the scale of the economy. Now that gives massive opportunity to the regions. They can be looking at their waste biomass and how they convert that into products. So we could envisage that there'll be smaller biorefineries, and that they could be hundreds of tons of materials, and there'll be a few core large biorefineries which could be, you know, the size of the current petroleum industries, refineries, which are massive. So which will then give us materials which we can sell into local markets, which is going to reduce our carbon footprint because we're no longer importing as much. And there will be global markets that we can be exporting to. Now, obviously, there will be a carbon footprint around us exporting. Just to point out that the top 5 oil refineries produce about 90 million litres of refined oil a day, and that's solely for making chemicals and materials. So that's a massive resource that's going to be slowly mothballed, or hopefully quickly mothballed, but it does give a huge opportunity for biorefineries, and New Zealand is incredibly well placed to be one of those players. So what will biorefineries do for New Zealand? Well, they will reduce our reliance on oil-based chemical imports, which is good. We've had numerous supply chain disruptions due to COVID. So that's an example of how, by being so remote, we are at the mercy of the rest of the world. There's an opportunity for us to become net exporters of high-value chemicals. And again, I say not really commodity, because that smaller amounts will have a less carbon footprint than large amounts of commodity chemicals leaving New Zealand. Germany, for example, has indicated that by 2050, it will have 40 rather large biorefineries constructed, but will still be net importers of chemicals for the European markets. And that's because, again, it's a massive shoes to fill as the oil industry sort of transitions away and we head down a bio-based route. It also gives us a new paths for regional-based economies, which can be based around Matauranga Maori-led research, ensuring that the taonga, which for some of our products, and Manuka honey is one of them, have sort of got taken off us, and we've lost that uniqueness, and we've lost some of the value. And it will also re-envisage the role of plant-based, the primary sector. It'll no longer be a sector that makes some food, or a sector that makes a log. It'll be the sector that makes a log and makes food and makes a whole lot of chemicals that we need to live in the modern world that we enjoy. There'll be 2 ways that this will happen in New Zealand. There'll be the evolution of using biomass residues and waste more effectively, and there'll also be opportunities as we go down this route for perhaps there will be new purpose-grown crops. And I would like to thank you for your time.
Thank you very much, Stefan. So Alec, while Alec just gets to sharing his screen, I'll briefly introduce Alec. Just to remind you, you can put your questions into the Q&A box. The chat has been disabled. So Dr. Alec Foster is the Bioproducts and Packaging Portfolio Lead at Scion, where he works and enables New Zealand companies to create, manufacture and utilise some of the bioproducts that Stephen's just been talking about for a sustainable future. He is currently leading 4 programs within Scion: bioplastics, composite products, indigenous fibres, and packaging solution. His technical expertise is in commercial R&D, product development, and he's specialised in biotechnology, chemical engineering, IT, and polymers. Having previously led one of the world's largest synthetic biology teams, Alec has successfully taken products from concept to scale and developed 40 patents and licensed many new technologies. So Alec has been with Scion for 6 months now, but he's got lots of experience to talk about, and I'll hand over to you now, Alex. So if you could share your screen.
Good morning. Unfortunately, it says that screen sharing is disabled at this moment. You cannot share the screen while the other participant is sharing.
Oh, so if you could stop sharing, Stefan.
Done.
That's better.
Excellent.
Okay, so good morning, everybody. So I'm going to be presenting on sustainable materials and packaging within Scion. I wanted to provide an overview of some of the stuff that we're doing. Stefan already presented how the world is changing, how the world is evolving, and this really plays into packaging and materials. It's going to have massive impacts in New Zealand, around the world, and there's a number of key themes that we need to be considering, a number of key aspects which are going to impact how we do things, how we think about materials, how we think about our packaging. Now, Scion has recently undergone a change. It's recently developed a new 10-year plan, and a big focus is upon sustainability. And we need to kind of transition the world, because we all know legislation is going to change. We all know consumer habits, consumer needs are changing. So the science and what we do within science also needs to change. And within the packaging space, we need to meet this. So we're moving far more towards sustainability, far more towards circular packaging, anticipating change, anticipating where we can help adapt, where we can help provide opportunities to New Zealand, because whenever there's a big disruption, there's new opportunities, new ways of doing things different. It's not simply about producing new drop-in solutions. My personal belief, nature provides the solutions, and we should be looking to nature to provide these solutions in new and different ways. And there's so much opportunity, so much things that we can be doing. It allows us to look at how we approach things from a value chain, how we look at things from localization to the materials used, to the way that we actually shop and use different materials. Now, one of the big aspects within Scion is our bioplastic development. So this kind of provides us a bit of a glimpse of the future. Now, we don't want to simply use polymers which have been generated from oil over the years. We need to be thinking about something different, using nature's plastics. Now, within Scion, we use fermenters, much like how we use yeast to grow beer. We can actually use fermenters to grow bacteria, which make different types of plastics. And on the screen, you can see a couple of examples of the plastics that we're making within Scion. And these are natural plastics, which importantly compost. They degrade both within a marine environment, but also in soil. So really cool type polymers, which have a variety of applications. Now, Scion is actually helping bring this technology into New Zealand. We're helping seed it with industry, and for the first time, New Zealand will be making making any plastics. So this is one of the really cool things. We're starting to be able to bring in new technologies which are smaller scale, which can suit our market, and provide a number of distinct and unique advantages. Now, here within Scion, we are expanding the types of polymers, trying to understand the qualities, the properties, how we can adapt them for different applications, different purposes, how we can make it cheaper. We're also starting to think about synthetic biology. So this is really manipulating those bacteria, changing the genes, making sure that they can make even better polymers, which will have greater value, more useful type applications, even beyond packaging. Another key area within Scion is fiber products. Now, as we go towards a more sustainable sort of approach, we need to actually minimize a lot of the plastics. So we've got to think about, when is a fiber solution best, when is a plastic solution best? And a lot depends on the particular application. All plastics aren't bad, all fiber solutions aren't the best solutions in all cases. We've got to think about the specific use cases. Now, one of the really cool things that we're getting in is a new fiber thermoformer. So this is a picture of it on the top right corner. So this has been on a boat, and it should be arriving any day soon within at Scion. And this will allow us to look at a variety of different feedstocks, a variety of different waste material, and see how we can make this into a variety of different formed products. So really cool. Also, you'll see what we describe as our white room. So this mimics basically a shipping container. So New Zealand, we export lots of things abroad. So you think of your zestfrees, all our apples that we export, lots and lots of food goods. It's really important that they arrive in good condition, because the actual waste associated with food production is much higher than the actual value of the actual fiber material. So if we lose 10% in our exports, that's a huge loss. So the better that we control our packaging, the better that we can understand the architecture, the coatings, the far better it's going to be in a sustainability sense. You know, we can ensure that much more of the material arrives in a good state. We can ensure that that there's no crushing, those type of aspects. So we're doing a lot of work around improving box performance, improving the coatings, improving the really how and when different packagings are used for different applications. We're also looking at aspects like foam, and I mentioned the molded fiber. Another aspect is we can go back all the way back to the tree and say we want to grow and breed a tree which actually has better fiber solutions, which will make a better end product. So thinking about your end state of a fiber packaging and thinking what would be the best tree that we should be growing today to help meet that need. Another key area for Scion is recycling and compostability. So we've got one of the few biodegradation facilities, the only one in New Zealand, one of the few in Australasia. So it's really cool. So we can actually understand how do different packaging solutions degrade over time. Are they compostable? Do they degrade in a home compost environment? Do they compost in an industrial composting facility? And we've recently commissioned a new disintegration facility. So that's really quite cool. So we can really start helping industry, helping their needs, really understand, is their material truly compostable? Is it affected by things like heavy metals? So things like the inks and those type of things. Are they impacting the environment with microplastics, contaminating chemicals? So we do a lot of ecotoxicity testing. So do plants grow in the soil afterwards? Do worms die? We also have some work looking at other types of plastics. Can we change their degradation properties by understanding, by introducing new properties, new enzymes, making new composites? And this is an example of such an activity. So here we've got an embedded enzyme which helps a plastic degrade, and you can see after 8 days you've got a nice kiwi. Now, the fourth area I want to highlight is the digital technologies, because lots and lots of spoilage is associated with food waste, as I mentioned before, and we can improve this with improving the transparency across the supply chain. Now, currently, things like heavy metals, they're too expensive, and they are associated with a lot of environmental impact, a lot of negativity, but we can move to beyond that. We can move towards a future where we actually understand different properties such as temperature, humidity, and actually be able to track materials, be able to verify materials. So really cool. So this is some examples that we've developed within Scion. So these are using biomaterials that have been coated onto cardboard, and these will help us in future be able to reduce a lot of the waste associated with our packaging, because if we can track it in real time, if we understand the variations over a continual process, over a network, we can help decrease waste with increased knowledge. Now, the final area I just wanted to highlight that Scion are working within is food contact compliance. So we help numerous companies within New Zealand with exporting, because legislation is continually changing, and our understanding of chemicals and how they migrate into food is really changing all the time. So, I read a paper just last week, a review by the Food and Packaging Forum, and they identified over 3,000 chemicals which have been identified as leaching into food, leaching into water from our packaging. Many of these, we don't really understand the long-term effects, the chronic effects over a prolonged period. And as rules and our knowledge becomes greater, legislation is going to change, and we're going to have to continually adapt. So Scion plays a really important role within our industry partners, understanding, say, things that can originate from the inks, adhesives, wax, things present from the recycling streams. We've got various chemicals that we need to be understanding, also helping industry understand where their packaging might not be suitable for a particular jurisdiction. For example, Europe will be very, very different to China, and we have a key role helping ensure that our exporters can export into those different markets. So really, for me, there was actually far too much for me to cover within a presentation. We've got lots and lots of activities within Scion, really cool stuff that we're doing, really trying to adapt to sustainability, really trying to adapt to a new environment, new packaging. And I just wanted to really highlight some of the key areas for us. So we're developing new polymer solutions, we're developing new fiber solutions, we're improving material end of life, and thinking about smart packaging to ensure sustainability. And that all needs to be kind of married up with food safety and compliance, because there's no point developing all these different materials, there's no point developing different packaging solutions if they don't meet the food safety and compliance regulations. So all of these combine, all of these help us develop new and different products. And every year, our team at Scion are working with approximately 100 companies doing this. So it's really cool, really exciting, and it's a really interesting space to watch. Thank you.
Thank you very much, Alex and Stefan. So we've got a few questions here. So the first one's from Eric Alterman. He wants a very interesting perspective. Thank you for sharing. And a question that came to mind, was there a potential role for GMOs in biorefineries? So I don't know who wants to answer that question, Stefan or Alex?
I can answer that. So I believe there is. At the moment, legislation within New Zealand prevents it. However, I would anticipate that legislation changing within the next 10 to 15 years, simply because the world is adapting. If you look at the US, a recent report said that synthetic biology, GMOs, are going to contribute, I can't remember how many trillion, but it was huge. I think it was 25 trillion to the US economy.
Wow.
So
Yeah.
it's going to have a huge impact on the world, and sooner or later it's going to have to enter New Zealand. Already, if you go to Countdown, you can buy GMO goods and eat them.
Exactly. Yeah, I know.
So there has to become a point where actually New Zealand exploits these, because there are a number of advantages, a number of ways that it can make us greener, improve the environment, improve the way that we do things. So it's really tapping into nature.
Yeah, okay. Thank you. So Juliana wanted to know, can currently the current oil refineries be updated to be biorefineries, or are biorefineries completely different and will need new infrastructure? Perhaps you could answer that, Stefan.
Sort of a combination. I mean, I've jokingly said that the New Zealand government should have brought Marsden Point, and we should convert that into New Zealand's first major biorefinery. It's close to a port, and that's where we could perhaps look at some of the forest residues. A lot of the capital equipment can be used, so there's a lot of fractional distillation and other units like that. But there would be some new capital investment required. So, but I guess the main thing about something like, say, Marsden Point would be that you already have quite a lot of your infrastructure in place in terms of power, water, consents, which I guess will be a big thing. If we look at something like one of our colleagues, another portfolio leader looking at bioenergy, there's a drive to make bio-based Jet A fuel. Planes are difficult to electrify for long distant flights because unfortunately the batteries weigh the same when you take off to when you land, and currently aircraft rely on the fact that they weigh less by the time you get to your destination. So somewhere like Marsden Point could potentially be making Jet A fuel from bio-based resources. There's already a pipeline to Auckland Airport, so New Zealand could be making its fleet of planes and the planes coming into it running on bio-based fuels now, if we chose.
Okay. Oh, interesting. Okay, so Elizabeth McGrady wants to know, Stefan, would the market for chemicals extracted from oil continue? Is a real opportunity for plants, those chemicals which are not extractable from oil? Is that the real opportunity?
The opportunity is probably in the two spaces. I mean, we will need to do some replacement of chemicals we get from the oil industry if we have any hope of meeting our climate change targets. It'll also, but it gives new opportunities. There are compounds we cannot make from the petroleum industry. And that's why we're in a neat position now where we can look to the past and say, well, what do we really need? Maybe some of the things we thought we needed, we just needed because we have them rather than we truly needed them. And how does a bio-based economy sort of give us new opportunities of products, which will be designed particularly around their life cycle? And not all polymers, just because they're bio-based, are good for the environment. An example would be polylactic acid. So while it's industrially compostable, it loses virtually none of its biomass if you throw it into the ocean. So you're still going to be killing turtles, just it'll be a bio-based plastic we'll be killing them with. So we just have to be careful that we're designing for purpose.
Yeah, I think you made a point about unintended consequences of change, and you made a comment about the carbon dioxide at oil at Marsden before. So I guess that's one of the problems we have is understanding what are the consequences of the changes. Just one question for Alec is: are there any? From Elizabeth, any issues with genetic modification of bacteria in these new sustainable markets?
There are a few issues. I think one of the things that we've kind of learned is initially a lot of fermentation type processes used sugars and they competed with food streams, and that was something that wasn't sustainable. So there's been quite a big shift away from using the easy to use like sugar streams that might come from food or compete with like food to more like geothermal activity. So we're using waste gases. The other aspect is legislation that needs to change, and that's going to be a big barrier within New Zealand, and until that changes, we are not going to be able to introduce genetically modified products made within New Zealand. The other barrier is we might be able to generate new polymers, new materials, but we've also got to be thinking about their end of life. So do we recycle those materials? Are we making those materials just to compost? So it's thinking about those materials in new and different ways. And currently, the recycling mechanisms simply don't exist within New Zealand, at least. They also, well, we don't have many of the recycling pathways for our current plastics, let alone some of the new ones that we're developing. So we're very much targeting at the moment compostable materials to kind of fill that niche.
Okay, well, thank you. Just a question from me. You commented, Alex, about China being very different in terms of export. Was that means that they're more stringent, or you said we have to do a lot of work to try and ensure our products met their? Are they more stringent or easier to get?
I think just different would be my perspective. I'm not an expert in this area, but what I would say is the legislation varies from Europe to China to the US.
Yeah.
And if you're an exporter, you want to be able to meet all three markets.
Yeah.
So that's a real challenge.
Okay. So what about either of you could answer this question? What is in terms of testing for safety of some of these bioproducts and nutraceuticals and foods? Do you do any testing? I heard you mention of testing the ecosystem, but safety testing the ecosystem, checking the worms still grow. But what sort of work is done on testing the final products is in terms of their safety and food safety?
So in terms of food safety, we do sort of like some chemical analysis. So various analyses to determine constituents within these different products. And that's quite a big activity within Scion. So this would be sort of like your GCMS, LCMS type activities. We've also got capability around the NMR space. So Stefan's a chemist on that. You can talk to this far better than I can.
We do so we do test to the EU standards. So we while we are not certified to do to provide certification, we work with partners who can. So that can be things like the Fraunhofers in Germany. There's Belgium, there's the UK. Sorry, I can't remember the names. So one of the spaces, so we're more at the research side of things. So a lot of the work we do is on NIAS, the non-intentional added substances. Now that's an important branch of research going on, even with our traditional food packaging now, saying, well, okay, well, there's all these regulations you've got to meet, and when you meet them and you think, well, my product's got to be safe, but along the process of making these polymers, making the packaging, and then putting your food in, there can be the things you didn't look for. So NIAS, and I'm sure anyone in the food space has heard that term, is one of the things that we're delving into with these new polymers, because unlike traditional polymers where we know probably a majority of the materials that may migrate into the foodstuffs, if we're going to be replacing those polymers with new polymers for very good reasons, then we still need to understand if any materials are migrating into the food which may compromise either its taste or its longevity or its safety. So yes, so we're more on the research side of things. If we want something certified, then we'll partner with external organizations who can provide that certification.
I mean, I think Alex made the point, there's a paper that said there's 3,000 different chemicals leaching into the food and water. So it's a bit of a worry. I guess that's what's currently happening with oil-based products. But,
yeah, I think it's tracked, and it happened in the 90s in Auckland when we developed new techniques with better sensitivity. We started finding things we didn't know were there. Okay. And that particularly around Auckland and the Waikato as well, looking at land that got converted into housing, but traditionally were sheep farms, and the sheep farms had sheep dip pits, and suddenly we had techniques which could detect a whole lot of things like DDT and other chemicals in the environment, and that really shifted the way that the councils had to deal with land management. And the same is sort of true for food and packaging now. We've got very sensitive techniques where we're finding things which, because we didn't know they were there, we weren't worried about them, but that's probably not a good reason to not be worried about something, just not knowing it's there.
Yeah,
but that sounds very paranoid. I'm not paranoid, but the things out there we don't know about that are out to get us.
Yeah, exactly. So, I mean, a key thing, I think you both have mentioned the role of legislation, and that's going to drive a lot, but consumer behavior is also going to drive a lot of the change, but it's really getting the two sort of aligned, I guess.
Yeah, the GMO is an interesting one because not all GMO technologies are equal. So I would argue that CRISPR is an accelerated evolution process. So it's like doing selective breeding, but not having to wait for a life cycle, for many generations, F generations of the plant. Yeah. You can get it done in a much shorter time, but it's really not, cutting out bits of a gene and sticking in genes and trying to make a batwing cat or something. It's a very different ballpark. It's about saying, let's make this plant better for purpose, but not having to wait for it to grow. Now, in some crops, food crops, there's very fast rotation, so it's more plausible to do, F1, F2, F3 sort of breeding. But in a tree you're going to leave standing for, decades, then it suddenly becomes a bit tricky if you need 5 generations to embed just by crossbreeding, because it's going to be, 300 years later, you'll finally have your product.
Okay, yeah, so there's a few challenges to address. Any further questions from the audience? I think everyone's gone quiet on that. Did you want to have any last comments, Stefan or Alec?
Just thank you everyone for taking your time to listen. If you have any further questions, just feel free to get in contact.
Yeah, Alec?
Yeah, just echo what Stefan said, and just that there's lots and lots of opportunity and lots of cool science.
Yeah, no, and hopefully New Zealand can be leading in it. So thanks for all the good work that you're doing, and thank you for giving up your time today, especially you, Stefan, when you're on holiday. So just to let you know, the next seminar is going to be held, we're going to hold it 1 week later because we've got Matariki on the last Friday of June, so it'll be held on the 1st of July, and we're going to be talking about the experience of remote auditing during in China during COVID, and that's going to be led by Professor Castell from University of Canterbury, and also with Chris Hewen. So Professor Pavel Kaska, from the University of Canterbury, and Chris Hewens, who's from MPI. So look forward to you all coming back in then, and thank you again to Stefan and Alec for your talk today, and for all of you for joining in. Thanks very much.
Thank you.